Hello everyone, welcome to our class. Today we will talk about the arrays in assembly. Actually, arrays, this concept is not so difficult if you understand the memory layout of your data. We talk about the memory layouts in C languages in other videos. If you are interested, go to check out another videos for this kind of concept. It's called bits and bytes, okay, and data representation in C. So before we start, just try to have a sense. Actually, assembly in array, the most important part is about the memory. So what's the data look like? It's 1 byte data or 4 byte data will totally affect the instruction you will need to support the array assigned, the value assigned or array data load the copy. Okay, so let's get started. So first one, before we do anything, the stack pointer ESP point to the top of stack. And what we actually do is we try to remember the EBP. So we got the update of EBP here, and we move the EBP to ESP. So right now, the EBP and ESP, they both point to this place, right? So this is a sender setup. And here we try to get the 32 byte for a machine. So 32 byte machine, we subtract the ESP. So we got here, we got some data here, and we make the ESP. Actually, we do not save any data. We just move ESP to this address, which means we can create some space for local variable. So this is part, create space for local variable. For local variable, how many space you need? You can do some computation, right? So in this case, we have a characters array, which is 16, and integer array, which is 4. So in this case, 4 times 4 byte, and 16 byte here. So in total, we need 32 byte. So how many space we need? 32 byte. So we create the 32 byte area here. Try to use to store the data. Okay, so let's take a look of how this data actually do. First part, we can separate this A and B in this case. So the first part, we try to separate 32. First 16 for A and next 16 for B. So we have A and B. So you can imagine that this is for A, this is for B. Okay, so for A, the first argument we have is A5 equal to A. A in ASCII code, the number is 97, which is equal to the ASCII code A. And we move it to EBP minus 11. What's the EBP minus 11? Remember, we saved the 32-bit machine here. So if you take a look of each line of this memory should be 4 bytes. We will talk about a little bit detail in the future why it's a 4 byte. But here, each like line of this one, you can imagine that is a 4 byte. So let's do some chunk of it. There's a 4, 4, 4, 4, 4, 4. And if we look at the 4 byte here, we can get something like this. So the top 16, we have a top 16 space here. Each grid is actually 1 byte. So if you look at the EBP minus 11, which is EBP minus 11? EBP minus 1, minus 2, minus 3, minus 4, 5, 6, 7, 8, 9, 10, 11. So actually EBP minus 11 got you the place here. Okay, got you space here. So minus 11 give you an area here. So which means this is actually the A5. Why? Why is it A5? This is A0. Okay, so we can take a look of the bigger one. So if we have A like this is A0. This is A1, 2, 3. and 4, 5. So can you see that actually this one map to this area, right? So this is how you match your array. You do EBP minus 11, which is actually equal to the array A5, this index. Array A5 this index. So why we use this like this magic number? Why we use this negative event? No, this is not so magic. This is just because we use a different way to compute the location of this array element. We do EBP minus 11, so we can get this like a A5 because A0 is here, right? So you start from A0. This is a very weird way in memory, but it's actually looking this way. You create the memory, you try to do the top. You try to like stack, do the top. And remember, it's actually a reverse way. It's actually a reverse way. You make it top. And how to do the top, from the top to do the computation, to do the allocation. The actually in the picture, you should look at in a reverse way. The bottom one should be the array first element in the array. The top one should be a last one, last element in the array, because it's work on in a reverse way. The memory address from 0 to maximum. Okay, so in this case, you understand. You probably can kind of understand what happens here. So we do we move A into this place, and we try to do some copy this value to EAX because we want to use the EAX. We try to use a value to copy this one to the EBP minus 10. What's the EBP minus 10? It's here. So we want to save the A6 to A5. So this is actually A6. We use minus 10 to get the A6. Then we store the value. Okay, so here's something you might be interested in is the format. We use a move VBL, move B, this kind of format. It's different to what we usually use, move L. So what's the difference between move L and move B? Move L is actually move 4 byte. And move B here is actually move 1 byte. Because right now we work on a character. Each character is 1 byte. So we want to just move 1 byte data into this particular memory address. So same thing here, we also have a move ZBL. What's ZBL means? We try to move the data, we try to move 1 byte data to a 4 byte registers. EAX is 4 byte registers. And this is just 1 byte data. How we actually do a conversion? We try to add a lot of 0 before the data. So actually we try to add a lot of 0. So how is actually do is Z. We do move, put a lot of 0, so we can extend the 1 byte data to a 4 byte. Then move it to a registers. And from these registers, we only get the last byte and move it into our memory. This is how everything works here. Okay, so let's take a look of the second part of this array. For the second part of the array, we also have a 16 byte here. The 16 byte, because it's an integer, so each value is 4 byte. So if you look at it in this way, this is EBP negative 32 here, and EBP negative 28, and EBP negative 24, EBP negative 20, and of course this 96, 16. So okay, so this is how actually we can work on this EBP stuff. So let me get rid of this part. Let's read the code one by one. First one, we use move L, which means move 4 byte. So we move the number 100. Why we move 100? Because 100 is equal to the ASCII code of character D. So we move character D here. We move 100. We move the character D to this space. So we got A0, B0, actually B0 equal to this D. The next one, we want to get the B3. B3 here equal to A5. So how we actually do this? First one, A5 is one character. It's just one character, one byte. We want to move one byte to this 4-byte data, which means we need to do some extension. So we actually do a move a byte, but this byte we put a lot of 0-byte extension and move the 4-byte data to EAX. Okay, we move a lot of data to EAX. So for this data of EAX, we still want to take a look of how we actually do the movement from the EAX to this data. And before we take a look of this line, let's see how we actually move at the end. We do the -20. So where is the -20? Because we want to get the data B3. B3 is where? Is this area, right? We want to put the data into this area. So we use the -20 to find out this value. So actually, in this case, we got the B3 here equal to the value we trigger from A5, which is, in this case, which is A. So this is how you move the data to a 4-byte space. So there's a difference between the first example and second example. The first example, we try to work on byte by byte because they are character, 16-byte character array. And the second example is an integer array. So every time we move the data, we got the integer array support. We got the integer support. We move 4 bytes together. Okay, so let's take a look of the last part we're missing, which is the third line of this code. The third line shows the move SBL. The difference is actually is use S. S means side bit. So when we move the data, we can choose, we put the O0 extent to this particular byte to a 4-byte, or we use a side bit, significant bit to do this. And why we put both here? Because we want to show you that actually there's a different way to work on the byte stuff. It's not easy to understand the byte, 1-byte stuff to convert to a 4-byte memory space, to convert for 4-byte data and store in your memory. Actually, if you want to understand this more, you should try to put some practice, play with some assembly code by yourself, and you will have practice with this in the future if you are taking this course. Otherwise, you can play with this code by writing some GCC-S to generate some assembly, read the assembly, try to understand how your compiler actually converts your code to this code. Sometimes it's all about the significant bit, is this unsigned integer or is it a signed integer? Everything about these details, you can also check other videos to understand what's the difference between unsigned and signed in C languages. And here, assembly also have a different instructions to deal with a different way you want to do the extension. And we just show you both way here to help you to understand what they actually do. This line is actually just copy the same data to the same register. So there's not much difference since here. Now, so this is for today. Today's video, we talk about array. For array parts, you can see actually we use a lot of offset, this offset concept, try to compute which memory location we need to store the data and how many bytes we need. If we want to store integer data, we need to store the 4 bytes into this memory address. If we just want to store a character, we store 1 byte. And when we get this data, we also need to pay attention on some extension. It's a 0 extension on 1 byte data. If we want to convert 1 byte data to 4 bytes, how to extend the other bits, other 3 bytes, the data for other 3 bytes. Is a 0 extension, or we want to use a significant bit to do this. And it's all related to the different type in C. It can be an unsigned integer, it can be a signed value, this kind of concept, okay? So I hope you enjoyed today's videos. Today just go through some like minor details in assembly, and I hope you enjoy it. Okay, so see you next time. The assembly array is interesting.